How to graph y equals the sine of x using the unit circle dance with proper vocabulary. This is part of the family of functions series. You will need paper and straight edge, or you can download this PDF and print it. Press pause as needed anytime during this video. Graph y equals the sine of x, but before we begin, we need to recall the unit circle values, and here they are. We also need to recall in what quadrants the sine is a positive number and in what quadrants the sine is a negative number. Remember that sine is the second coordinate of each point on this unit circle. Press pause, resume when you're ready. The sine is a positive number in quadrants 1 and 2, and we'll highlight those right now. Notice all these second coordinates are positive numbers. The sine is a negative number in quadrants 3 and 4, and we'll highlight those as well. To assist you in remembering the unit circle values, we're going to separate these values into what we call families. This is the axes family, that is the values that are at the end of each of the axes on the unit circle. And these are the 5 values that you should just know. Press pause, resume when you're ready. So the sine of 0, 0 lands here, and the second coordinate of that point is 0. So the sine of 0 is 0. The sine of pi over 2, which lands here, the second coordinate is 1. Sine of pi, 0. Sine of 3 pi over 2, negative 1. And the sine of 2 pi back to 0. Press pause, resume when you're ready. The pi over 6 family, these are the 4 values you should just know. Press pause, resume when you're ready. The sine of pi over 6 in the first quadrant is positive 1/2, that second coordinate there. 5 pi over 6 in the second quadrant, the sine is also positive 1/2. The sine of 7 pi over 6, which lands in the third quadrant, negative 1/2. And the sine of 11 pi over 6, also negative 1/2. Press pause, resume when you're ready. The pi over 4 family, these are the 4 you should just know. Press pause, resume when you're ready. Sine of pi over 4, positive radical 2 over 2. Sine of 3 pi over 4 in the second quadrant. Second coordinate is positive radical 2 over 2 also. But in the third quadrant, the sine of 5 pi over 4 is negative radical 2 over 2. And in the fourth, the sine of 7 pi over 4 is negative radical 2 over 2. Press pause, resume when you're ready. And the pi over 3 family, these are the 4 values. Press pause and then resume. The sine of pi over 3 is positive radical 3 over 2 in the first quadrant. The sine of 2 pi over 3 is positive radical 3 over 2 also, but in the second quadrant. While the sine of 4 pi over 3 in the third quadrant is negative radical 3 over 2. And the sine of 5 pi over 3 in the fourth quadrant, negative radical 3 over 2. Press pause, resume when you're ready. So here's a quick summary of all 4 families, beginning with the axes family. The sine of the axes values is either 1, 0, or negative 1, the second coordinate there on each of those points. The sine of pi over 6 values is either positive 1/2 or negative 1/2. The sine of pi over 4 values, the second coordinates are either positive radical 2 over 2 or negative radical 2 over 2. And the sine of pi over 3 values, either positive radical 3 over 2 or negative radical 3 over 2. Press pause as needed. To graph y equals the sine of x, we need to do two things before we can begin. First of all, the x-axis must be calibrated in fractional parts of pi. And then the y values need to be approximated with decimals. Those irrational numbers need to be approximated so we can plot them more easily. So to calibrate in fractional parts of pi, we're looking at all these values here, and we should know the least common denominator for these values. So press pause when you figure and resume when you figure that out. So the least common denominator is 12 for these numbers here. So when we create our axis, we need to calibrate the x-axis to show every pi over 12 unit. So in this case, this would be 1 pi over 12, then 2 twelfths, 3 twelfths, 4 twelfths, 5 twelfths, 6 twelfths simplifies to pi over 2, and so on. You can either download and print the PDF with the trig axes we created, or you can create your own trig axes with a centimeter ruler, your choice. We suggest that you let each half centimeter represent pi over 12. That would mean that 3 centimeters would be 6 pi over 12, or pi over 2. And 12 centimeters would be the distance from 0 to 2 pi. On the y-axis, we're going to say let 1 unit be represented with 2 centimeters. And you may wonder why that's the case. Well, pi over 3 is approximately 1. It's a little bit bigger than 1. So pi over 3, which is 4 pi over 12, would be 4 of these, and 4 times a half is 2. So 2 centimeters would be about what 1 unit is. And we're doing that so that the units are proportional or square. Draw your axes or print them and use the PDF. Press pause, resume when you're ready. The y values need to be approximated with decimals. So right now, use your calculator to rewrite each of these irrational numbers as decimal numbers rounded to the nearest thousandth or showing 3 decimal places. Press pause, resume when you're finished. So radical 3 over 2 is approximately 0.866 rounded to 3 places, and the square root of 2 over 2 is about 0.707 rounded to 3 decimal places. Please make note of these two values as we will use them often. Press pause. So let's finally graph y equals the sine of x. Draw your axes or print and use the PDF. That's how we'll start. Again, we'll recall the decimal approximations to those two irrational numbers. We're going to create a table for each quadrant and then plot the ordered pairs. So here's our first quadrant, including the axes values. Copy and complete this table for quadrant 1. Press pause and resume when you're ready when you have these filled in. These are the values that you should just know, and then we'll also use decimal approximations for these. We'd like you to plot those points right now. Press pause, resume when you're ready. So here's 0, where 0 lands here on the unit circle. The sine value is 0, so we'll plot the origin, 0, 0. Pi over 6 lands right here. The sine of that is 1/2, the second coordinate of that point. Pi over 4 right in the middle of the first quadrant. Sine is radical 2 over 2, which is about 0.7, so over 3 pi over 12, which is pi over 4, and up 0.7. Pi over 3 is 4/12 pi, up about 0.9 almost. And pi over 2 lands right there on the top, and the sine of that is 1. Here are the values for the quadrant 2. Copy and complete the table. Press pause when you've completed it and resume. These are the values you should have, including the decimal approximations. Plot the points, press pause, resume when you're finished. 2 pi over 3 lands in the second quadrant. The sine is radical 3 over 2, which is about 0.9. So over 2 pi over 3, which would be 8/12 pi, up 0.866. 3 pi over 4, the sine is square root of 2 over 2, which is about 0.7. 5 pi over 6, which is 10/12 pi, up a half. And pi lands right here, and the sign of that is 0, pi 0. Copy and complete the table for quadrant 3. Press pause, resume when you've finished completing the table. And these are the values you should have. Plot the points. Press pause, resume when you're finished plotting the points. Seven pi over 6 lands in the third quadrant. The sign is negative a half, so over 7 pi over 6, down a half. 5 pi over 4, sign is negative radical 2 over 2, so over to the right 5 pi over 4, down about negative 0.7. Sine of 4 pi over 3, down about negative 0.9. And at 3 pi over 2, it's exactly negative 1. Copy and complete the table for quadrant 4. Press pause, resume when you have completed the table. These are the values, so we'll go ahead and plot them. Press pause when you've finished plotting the points. Five pi over 3 lands here in the fourth quadrant. The sign is about negative 0.9. 7 pi over 4, about negative 0.7. 11 pi over 6 is exactly negative a half. And at 2 pi, back to 0. So we're going to connect the points as follows. You can stay with us on this one. In the first two quadrants, it's a full frown, okay? Full frown. And in the third and fourth quadrants, it's a full smile. Pause is needed. Resume when you're ready. So we want to discuss some terminology for this. First of all, the shape of the curve is called a wave. Press pause. Resume when you're ready. It is a series of frowns and smiles. Pause is needed. Resume when you're ready. Mathematically, though, we use the phrase, this curve is concave down in the first and second quadrants, and it's concave up here for the values in the third and fourth quadrants. So concave down versus concave up. Pause is needed. Resume when you're ready. The point where the curve changes concavity, that is, changes from concave down to concave up, that is a frown to a smile, that point, and also the point where the curve changes from concave up to concave down, is called an inflection point, or they're called points of inflection. So when it changes concavity, those are key points called points of inflection or inflection points. Press pause as needed. Resume when you're ready. The top point of a frown is called a maximum point, which occurs here at pi over 2, 1. The bottom point on a smile is called a minimum point at 3 pi over 2, -1. Pause is needed. Resume when you're ready. So there are 5 points of interest, or key points, on a sine wave. There's a max point, a minimum point, and 3 points of inflection. Since the sine curve, or wave, repeats, we say that the graph is periodic. And the period of the wave is 2 pi. Pause is needed. This is the conclusion of the video.